Have you ever really stopped to think about what's happening under the hood of your car? I mean, it's just pure, controlled chaos. A series of tiny explosions, thousands of them every single minute, all working together perfectly. Today, we're going to pull back the curtain on the incredible machine that harnessed that chaos and literally powered our world for over a century, the internal combustion engine. It really all boils down to this one kind of mind-blowing question. How in the world do you take a tiny bit of fuel, create a literal explosion, and then somehow channel all of that incredible power to move a massive 2-ton car down the road? It sounds like magic, but it's actually one of the most brilliant pieces of engineering you'll ever find. So, to really understand the engine, we first have to get a handle on where its power comes from, that tiny, super violent reaction that makes the whole show possible. Let's start with the absolute core idea behind everything: combustion. Okay, so what exactly is combustion? The slide says a rapid oxidation process, which sounds a bit academic. But the only words you really need to remember are rapid and releases energy. Essentially, it's a very, very fast fire. And an engine's whole job is to contain that fire, capture that sudden burst of heat and energy, and turn it into motion. You know, the recipe for this power is surprisingly simple. It's just like making a campfire. An engine only needs 3 things to work. You need fuel, like gasoline. You need an oxidizer, which is just the oxygen it grabs from the air. And you need a little bit of heat to kick the whole reaction off. That's it. The entire complex engine is really just a very sophisticated container for the simple fire triangle. And this right here perfectly illustrates the engine's true purpose. It's an absolute master of converting energy. First, it starts with the chemical energy. That's locked inside the fuel. Combustion turns that into thermal energy, which is just heat. That intense heat jacks up the pressure of the gases inside. And finally, that super high pressure gas has to go somewhere, so it expands, pushing on stuff and creating motion. It's this beautiful 4-step chain reaction happening over and over again. Okay, so let's get into our first major classification. When you're designing any kind of heat engine, the very first question you have to answer is a really big one. Where does the fire happen? Are we going to put it inside the machine or outside? And this brings us to what I call the great engine divide. On one side, you have external combustion engines. Think of an old steam train, right? The fire happens outside the engine, in a furnace, and it's used to boil water to create steam. But on the other side, you've got the internal combustion engine, or ICE for short. This is where the bang happens right inside the working parts of the engine, and that's the one we're going to be focusing on. So, now that we know we're talking about an internal combustion engine, we can start to get a lot more specific. I want you to think of this next section less like a boring list and more like a design menu an engineer would use to build the perfect engine for any given job. So the first choice on our menu is, how do you start the fire? A spark ignition or SI engine uses that spark plug we're all familiar with to ignite a mix of gasoline and air. But a compression ignition or CI engine, oh, this is cool. It does something amazing. It uses pure pressure. It just squeezes air so incredibly hard that it gets hot enough to instantly set diesel fuel on fire the moment it's sprayed in. No spark plug needed. That incredible compression is why diesel engines have so much raw pulling power. Next up on the menu, how do you capture the force from that explosion? Well, the most common way is with a reciprocating engine where you've got pistons moving up and down inside cylinders. But there's also a much wilder design called a rotary engine, which uses a spinning triangular-shaped rotor. They're incredibly smooth and really powerful for their size, but historically they've had some issues with things like fuel efficiency. And that's why the classic up-and-down piston design is still king of the road. And this table here really shows how those design choices have a domino effect. If you follow the row for spark ignition, you see your method is a spark plug, which means your fuel is going to be gasoline. But if you follow compression ignition, your method is high pressure, so your fuel is diesel, and your key part is a fuel injector. You see? That one choice at the beginning really dictates the whole system. Okay, so we've covered the theory and the big classifications. Now let's zoom in and meet the actual hardware. It's time to take a look at the anatomy of the engine and really see what these parts are and what they're doing. Let's think of the engine's main structure like a 3-story house. Up on the top floor, you have the cylinder head. That's what lets the air and fuel in and the exhaust out. The middle section is the cylinder block, and that's where all the action happens with the pistons. And then the bottom is the crankcase, which basically just holds all the oil that keeps things running smooth. And if the engine is a house, then the piston is the main character of our story. This is the component that gets hammered down by the incredible force of that combustion. It directly translates all that pressure from the explosion into a powerful straight-line motion. I mean, it really is the heart of the engine.
But hey, the piston can't do its job all alone. It has these tiny but absolutely crucial helpers called piston rings. The top rings act like perfect weather stripping, creating this incredibly tight seal to keep all that explosive pressure trapped. And then the bottom ring is all about oil control. It keeps the cylinder wall lubricated while scraping away any extra. They are truly the unsung heroes of the engine. So that piston is part of a bigger team. It's attached to a connecting rod, which is then connected to the crankshaft. Now, the crankshaft is the real genius of the system. It's the part that masterfully converts the piston's straight up and down motion into the spinning, rotary motion we need to turn the wheels. It's basically the exact same idea as your legs pushing pedals on a bicycle. All right, you've learned the principles, the classifications, and the parts. Now comes the really fun part. Let's put all that knowledge to the test. This is your chance to think like an engineer. But first, let's just do a quick reset with the core definition. Remember, the entire point of this incredibly complex machine is simply to turn the chemical energy stored in fuel into real mechanical motion. Everything we've talked about serves this one single purpose. So here it is, your pop quiz. You open a car's hood and you see a spark plug. Just based on seeing that one component, how would you classify this engine? Well, if you said spark ignition or SI, you are exactly right. That one single part tells you the ignition method and the most likely fuel type. Gasoline. See that? You just reasoned your way through it like an engineer. Nicely done. And we'll end on this thought. For over 100 years, the internal combustion engine has shaped our cities, our economy, our whole world. It absolutely defined the 20th century. So the question we're left with is, what technology is going to be the engine of the 21st?